So very happy to be here with our company. We're gonna give you a little bit of why, what, and how around storing energy. So we make battery supercapacitors out of a quite unique material recipe, and then combining that with, I would say, a solid combination of existing manufacturing techniques in the printing and coating area. So that's the connection from us to here, I would suppose. So let's go. We charge wood with energy. It's a material in nature that is called lignin, and that's one example of a residue stream from a piece of wood. About 30% of the tree is lignin, and that is used as at the best as some kind of biofuel in the process for producing pulp. So that's turned into powder, and that powder can be used as part of a recipe for storing energy. Actually, you can use the technology to store energy in sort of larger type of cells. This is a more traditional shape of a cylindrical cell. It can be slightly bigger, and you can make smaller cells. I'm fiddling around here with a. This is the product that we do right now. It's a smaller type of flat, thin cell. So by combining the lignin as part of the slurry for doing the electrodes with a cellulose separator, typically, carbons and binders and organic polymers, you have a recipe that makes it possible to store energy. And then the question is, would that material be enough to save the world from well, when it comes to the need for storage? So if you make a rough calculation on the need for large-scale storage, you would need to fill the equator all the way around the globe to be able to store as much energy that is needed to go from fossil to fossil-free energy storage. So it's a huge amount of containers. But that, from a sustainability point of view, would only need like 2% of the world's lignin. So this is a truly scalable storage technology. But then you get a question is, can you make a commercial product in short time? Even that's a possibility. So we have found in our business calculations that the big component, which here is a bigger type of cylindrical cell, needs to have the same cost level as the small component in the magnitude of one euro. So that have triggered us to, as a company that comes with a new technology, to go into the smaller component first, and that connects maybe better to the community where we are right now. So with the small components, we work as phase one for the company on energizing things like sensor nodes. And we see a second step for the technology, the storage technology itself, to go towards energizing buildings and the big thing, the big container thing in the end, as being step 3 for us as a smaller company to get going. So zooming in then to the powering of sensors, we see a huge market for the small component only, and you can make a very big difference with the small component. For example, in the fields of smart buildings, we heard about asset tracking in the previous talk, smart labels. Those are huge volume areas for many small components that can do a very big impact on the planet. So looking just into the smart building side, we can see that like 30% of the world's CO2 emission is connected to actually running buildings. So by being smart on light, heat, the utilization of buildings, and also you can also save pure money by having sensors and more sensors in the buildings. You can make